So the syllabus specifically asks us to look at the location, the process, and the result of chemical weathering, physical weathering, and biological weathering. For chemical weathering, they ask us to look at hydrolysis and carbonation. Usually as teachers, we teach oxidation as well, but the syllabus specifically asks for hydrolysis and carbonation. Physical weathering, they ask for frost action and exfoliation. Sometimes we teach other things too, but the syllabus specifically asks for these two. And then biological, we just teach biological itself, okay? So, weathering. There's a song about weathering that I like, but it's super old. It says, you know about weathering, break down that rock with weathering. The thing is, that's all the song is saying, so I didn't put it in there. Anyway, the point is that weathering is the breaking down of rock. That's a simple definition that you can use. But what is more important is that you include this. In situ. Syllabus asks us to include that. So if you get a question that is asking you to define weathering, do not just say weathering is the breaking down of rock. You must include the fact that weathering is the breaking down of rock in situ. So that means it is in its original place. There is no movement with weathering. Weathering itself does not move anything. That's another process entirely. Okay? So weathering itself, all it does, it breaks down the rock. All right, so the rock does not move while it is being broken down. So now we have different ways that the rocks will break down. That is how we have the physical weathering, chemical weathering, and biological weathering. So from those three words, physical, chemical, and biological, those can already give you a pretty good idea of how the rock is going to be broken down. And it's easy for you to define them too, because once you already know what weathering is, then it's easier for you to break down the others and come up with your own definition if you don't remember the exact definition that you were given in class, right? So physical weathering. This refers to the physical breakdown of rock without a change in the mineral composition of the rock. So when we say mineral composition, what we're talking about? Let me give you an example. So I have an Oreo right now, right? Biscuit. No, let me use crackers. So I have a crackers. I have Excelsior crackers. Most of you are Jamaican. So I have Excelsior crackers, and I'm about to put it in my, what you put your crackers in? You put your crackers in tea or porridge or what?
Porridge.
Porridge. All right. So I'm about to put my crackers in my porridge. I don't want to put it in there whole. So I start to break up my crackers, and drop it in the porridge. So the breaking up of my crackers in my hand, that is me physically breaking down my crackers, making it into smaller pieces, but I have not changed the mineral composition of my crackers. I don't change nothing about my crackers except the size, the physical size. Understand me? So physical weathering is the physical breakdown of the rock without changing the mineral composition. We also call physical weathering mechanical weathering. So anyone they use on the exam, you should be able to understand what it is. So this just causes the rocks to be broken down into smaller pieces. No chemical changes would take place. So we have different types of physical weathering. We have, well, the types that they ask us to look at. We have frost action and we have pressure release, which is also called exfoliation. So the syllabus specifically asks us to look at, hang on, what it is, All right, so here, the location of it, where it can be found, what is happening, and what it results in, right? So those are the specific things that we're going to look at. So the first one is frost action. So from here, frost, what that mean? What that sound like? Yeah, ice, good. So it's cold. So we already know just from the name of it. Frost action. It's also called freeze thaw action. We already know that this is happening in cold areas. Yeah, so frost action, this is the form of weathering that is also known as freeze thaw action, where it happens. We also call it frost wedging as well. So from you see the frost, you know what we're talking about. You know that it is the cold one relating to ice. All right. Where it happens, it's fluctuating. What does fluctuating mean? Yeah, area where the temperature is high at this minute, at not really this minute. Like it's high today, and then tonight it really, really cold or low, and then it's cold, hot, cold, hot, cold, hot. So it's not stable, right? So it occurs in these areas around 0 degrees. So 0 degrees, we know that that is freezing point. So we have freezing taking place and then thawing taking place, freezing taking place and then thawing taking place. So that is where the frost action comes in. So before we look into the how it happens, yeah, I want you to think with me. I like using real life examples that you can actually relate to. So it helps you to understand it in your exam, right? So if you're going there and you forget certain things, you can still remember what happened in your kitchen, for example. So let us say we put a bottle in our freezer, full 1 bottle of water, put it in the freezer. We leave out, go school and leave it in there. Come home, we're not take it out because we'll use it tomorrow morning. Tomorrow morning, we leave out, go school and leave it in there again. What's going to happen to your bottle? To expand, yes. So my bottle is going to start getting bigger. My bottle going to start stretching. Right? So that is the expansion that is taking place. Same thing with my rock. So if I take out my bottle and it thaw out, and I put in back the bottle and it freeze again, and take it out and it thaw out, put it in and it freeze again, the bottle is going under pressure. The bottle is under pressure. So this minute, it contracting. The next minute, it just getting wider. The next minute it getting smaller, etc. So the freezing and the thawing puts pressure on my bottle. And as somebody said before, eventually my bottle is just gonna burst, right? Same thing happens with frost action. So because we said this happens in areas where the temperature is fluctuating, meaning it up, down, around 0 degrees. So this minute it freezing, next minute it not freezing. So water will find its way into little cracks that are inside the rock. So these cracks that are inside the rocks now, that may be very, very small. Once the water finds its way in there, when the temperature drops, when my temperature drops and it gets really, really cold, this water that I have inside my rock is going to freeze. And the freezing causes it to expand or causes it to widen. Then when my temperature rises and it gets warm, my ice that is now inside my rock is now going to melt. So I will have my water in there again. So then it is going to contract. So this process that is repeated over and over, it is going to, just like the bottle in the freezer, it is going to cause my rock to be shattered. My rock is just going to burst or fall apart. So this is what it would look like. So my water fills up a crack that is inside my rock. it freezes to ice, expansion is taking place, and because of that expansion, it causes my rock to break apart. Next one is pressure release. Remember when we spoke about the sedimentary rock and we spoke about the layers that are there, but once you have something that is constantly on it, it's pressured and compacted. Do you remember that?
Yes, yes.
All right, so this is a little similar. The only thing is that it's not water that we have, it's overlying rock. So we have our rocks that are below the Earth's surface. For example, if we have some intrusive igneous rock, because it is intrusive and because it has cooled and hardened below the Earth's surface, we would have things on top of it, constantly pressing it down, constantly pressing it down. When those things are removed, when those things are now exposed, then our rock now it's almost as if it finally has a chance to breathe. So it's like if you're coming from foreign and you're packing your suitcase, right? And you push it on, push it on, push it on, push it on, push down everything because you want everything fit until the suitcase finally zip. Whenever you open back that suitcase, everything that is inside, it's almost as if it's going to take back its form. So it's going to just rise up. And then you might start saying, then, oh, all of this did fit. It's the compaction process that it would have gone through. So for pressure release, it's kind of the same. So this form of weathering is also known as exfoliation or onion peeling. You see, like how with onion, you have the layers, the different layers. And like with exfoliation, when you're exfoliating your skin, ladies, well, gentlemen too, you are just rubbing to get off the dead skin off the outside of the layers. It's a similar situation. So how this one works is that the overlying rock is removed by erosion or whatever natural process. So it causes the rock that was underneath under all this pressure to now be released. So when this rock is now released, it causes the rock to finally expand, just like the closing of the suitcase. It causes the rocks to finally expand. So this expansion now, it causes it to just crack. It causes it to crack, but it cracks in a parallel way. So it's just like you're peeling off the parts of an onion. So how you have this layer you take off it, and the next layer look the same and you take off it, next layer look the same and you take off it. Similar situation here. So this causes the rocks to develop several layers which are similar to that of an onion. So over time, these sheets of rocks will break away from the rock mass itself. So this is what it would look like in real life, right? So you would have, this is my underlying rock here. Well, all of this was once underlying rock, but everything that is on top of it has been removed through erosion. So because this rock is now exposed, it's exposed to the wind, it's exposed to water, etc. It starts peeling off in little layers. Do you see how they look? They are the same shape as the underlying rock, but it's almost like you're lifting off a top part of it. Do you see that? All right, so that is how that process works. That is why we call it exfoliation. So imagine that you're rubbing your skin and you're taking off those outer layers, but eventually something else is gonna come back and you're taking off those outer layers just the same. So overburden rock is eroded, so the amount of pressure that would have been on the rock that's underneath, it would have been removed. Once it's removed now, it's like the rock can finally breathe. So it expands, and that is when the cracks develop, and that is when this rock starts breaking apart. So notice with those two that we did, with the frost action and with this pressure release, the chemical composition of the rock does not change. All that we have done is broken up the rock into smaller pieces of the same thing. So this is another one that we look at as well, temperature change. Temperature change is somewhat similar to frost wedging, frost action. So this happens though in areas that are very, very hot instead, such as the Sahara Desert. So they have large daily range of temperatures. So in the deserts, people know the deserts as being really, really, really hot, but they don't know that in the nights, the desert is really, really cold, extremely cold. So it is a large variation. It's very different temperatures between the day and in the night. So during the day, the temperature is high. There's no water in the rock like frost action, but the high temperature itself causes the rocks to expand slightly. During the night, you have the low temperatures. It causes the rocks to contract slightly. So it's like breathing up, down, up, down, up, down, up, down. So every night is one way, every day is another way, every night one way, every day another way. So this repeated expansion and contraction causes the cracks to form in the rocks. So eventually they just burst and fall apart. So this is what it would look like. So chemical weathering now. Let's go back to the crackers. So the crackers in the porridge. So with physical weathering, I break up my crackers and I put it inside my porridge. With chemical weathering now, I don't break up my crackers. I just take the entire crackers and put it inside the porridge. What's going to happen to the crackers? Going to get softer. Good. What causes it to get softer? If you notice now, my crackers would now have a different chemical composition. So I have broken down my crackers just the same. It has gotten broken down inside the porridge, but it's broken down in a different way. So the chemicals would have acted on the crackers, causes it to soften, which really is still weathering it. It's causing it to break down, right? So physical weathering, I would have just broken down my rock without changing the chemical composition. Chemical weathering, I am breaking down my rock, but I am altering the chemical composition of it. I'm changing the actual makeup of it. It is some reaction that is actually causing the rock to break down. So we have a change in color, texture, or the actual makeup or the form of the rock that causes this rock to be broken down as a result of some chemical that has been released, right? Do we understand the difference between chemical and physical weathering? So for chemical weathering, there are different types as well. The syllabus specifically asks us to look at hydrolysis and carbonation. So there are other types. Most times teachers may teach oxidation as well, but the syllabus specifically asks us to look at hydrolysis and carbonation. So those are the two types that we are going to be looking at. So hydrolysis. Look at the word hydrolysis. What's the root word in there? Or what's the prefix? What's the prefix in the word?
Hydro.
Hydro. Good. What does hydro mean?
Water.
Yes. So one form of chemical weathering is hydrolysis. So we have the acid in water that is working to dissolve minerals within specific rocks. So it's not like it's every rock this going to happen to. So if we have acid rain, for example, that's falling outside, it doesn't mean that every single rock that is outside is going to just start eroding, or every single rock that is outside is just going to go through that particular process of chemical weathering. It doesn't mean that. So it acts on the minerals within specific rocks. This is how it happens. So hydrolysis is the reaction of a substance with water. So the rainwater mixes with the carbon dioxide and it forms acid rain. It forms a weak carbonic acid, right? So this acid reacts with the minerals in the rocks and it causes them to dissolve. So for the hydrolysis, sometimes we refer to it as solution. This changes the chemical composition of the rock and causes them to be broken down. Rocks that are high in minerals, such as feldspar, would dissolve to produce clay, and the process would also turn sodium minerals into saltwater solutions. So the rainwater is basically selecting what type of rock it affects and what specific mineral inside the rock is affected. So it doesn't mean that the rock itself is just going to wither away and you see nothing at all. It doesn't mean that. All of the other minerals that are in the rocks would have been left standing. So look at the picture that we have here. You can see that only some sections of this particular rock has been broken down, right? You can see that only some sections have been broken down. Not all of it is made up of the same material, so it has altered the chemical composition of the rock. So these areas that it affects specifically, these areas would have been broken down. So eventually, because you have the rock looking like this, eventually more of it will break down just the same. So the next form, well, CXC did not specifically ask for this, but you know, another form of weathering is oxidation. So oxide, iron oxide. So this, in this case, the combination of a substance with oxygen. So oxidation is the reaction of a substance with oxygen. Remember, hydrolysis is the reaction of a substance with water. Oxidation, reaction of a substance with oxygen. So the oxygen in the acid rain will react with iron present in rocks. When the irons in rocks react with oxygen, it forms iron oxide, which weakens the rock. So like maybe if you're at school or if you're at home, if you have a grill or something, most times I see it at school. I don't really see it at home. Like on the railings at school, when you hold on to it and you look at your hand, you see rust. Do you see that sometimes? So it would have been basically the rain or the oxygen that is reacting to the iron, which weakens it and causes the rust to take place. So similarly with oxidation, the oxygen reacts with the iron that is inside rocks and causes it to break down. So we get that brownish reddish color, kind of like what we see in there. So it's almost like the rock is rusting. You see sometimes some old truck park out in some place where water can touch it consistently and the oxygen, and then it causes that to rust as well. So it's just the iron reacting with the oxygen. Another form of chemical weathering is carbonation. So we can see the carbon in this one as well. Carbonation, which is the process of carbon dioxide dissolving in a liquid. So look at what we have here as well. So again, just like hydrolysis, it's not as if it affects all of the rock where everything is dissolved. It affects the part that it can affect, and it will leave the rest of it standing. So you will have all of these holes in this particular case here. So with carbonation, rainwater contains carbon dioxide, which produces a weak carbonic acid. The acid reacts with rocks composed of calcium carbonate. So limestone is an example that is made up of 50% calcium carbonate. So limestone will go through this process of carbonation a lot. Okay, that is how we would have all of the different limestone features being formed, like the clints and the grikes and the stalactites and the stalagmites and the pillars and the underground cave, etc. So it is as a result of the process of carbonation that would cause all of these features to be formed, because limestone is made up of 50%, over 50% calcium carbonate. So this process causes the limestone to dissolve, and it is later removed in solution. So it's dissolved into the water and then it is washed away, right? And this produces distinctive landscapes. What are these landscapes called? These limestone landscapes called? Karst landscapes or karst scenery. All right, so this is just an image of how it would take place. So this is the carbonate bedrock, and we have the rain that is constantly there. Eventually, you can see that this area would have dissolved and given us somewhat of a pond. And then water will continuously be seeping through here, so it will start giving us all of the other features in the limestone. Another example here, blocks of sugar. What I actually do in class with my students to show them carbonation, we use chalk. So chalk is made up of limestone. So we use chalk and we use Pepsi. So Pepsi, yes, the very Pepsi that we drink, it is carbonic acid, weak carbonic acid. We do in class, we use chalk. We just throw out some Pepsi in a cup and put a chalk in it. And within not even minutes, within seconds, you start seeing the chalk pieces start falling apart, because the carbonic acid that is inside the Pepsi starts reacting with the calcium carbonate that is inside the chalk. Eventually, everything dissolves. It just wears it away completely, right? So that's a nice experiment that you can do with your little sister, your little brother or something, or use sugar cubes like this one. So limestone is made up of calcium carbonate. When it dissolves in rainwater, it makes a weak carbonic acid. When the carbonic acid comes in contact with the limestone and it passes through the joints and the bedding planes of the rocks, then it forms that calcium bicarbonate and it dissolves the material and carries it away. Next one is biotic weathering. So what's the prefix here again? You notice how I'm bringing up lots of prefixes and something? Those are little things that can help you to remember things in the exam. You know, sometimes you go in the exam and you get a little flustered and you feel like you don't remember nothing at all. These are little things that can help you, give you little prompts. So what's the root, the prefix in biotic? Bio, very good. What does bio mean? Living things, lovely. So if we are talking about biotic weathering, we're talking about how living things, such as plants and animals, how they weather rocks or how they cause rocks to break down. It sounds simple, don't? Like once you understand what the word means, you can figure out your definition right away. Okay, so biotic weathering, this relates to the role plants and animals play in breaking down rocks. So we're going to look at it from two ends, what the plants do as well as what the animals do. Biotic weathering by plants. So look at the pictures that are there. Let us use this one first. We see this one a lot. So in this case, the roots of the trees, it's growing constantly, so it's moving. So it forces its way into any cracks that is inside the rock. And because it is constantly growing and it's constantly forcing its way into the rocks, it is going to cause them to expand, and eventually it is going to break the rocks apart. Follow me? So if I was to put this one with the tree on the physical weathering or on the chemical weathering, which one would I put it under?
Can you repeat, Miss?
If I was to put the one with the tree, biotic weathering by the plant that is actually breaking away the rock, if I was to put it under physical weathering or chemical weathering, which one would it be? So that would have been physical biotic weathering, because it is using the root to simply break away the rock without changing the chemical composition of the rock. So what about this one now? What are these green things called? It's moss. Very good. So the moss here, it is a plant, yes, but its presence on the rock is actually causing it to break down. So the moss releases different acids, and it causes the rocks to dissolve. So anything that it grows on, it's kind of like mold on bread or something. So it releases different acids, and once it grows on it and it starts releasing the acid, it causes the chemical composition of the rock to change. So it alters the rock's chemical composition and causes it to become weak, so the rock will eventually break down. Right? So that is weathering by plants, but what other type of weathering is it?
Chemical.
Very good, chemical, because this would have been changing the chemical composition of the rock because it's releasing acids that causes it to break down. So you can see that in this one, we have chemical biotic weathering, and in the next one over here, we have physical biotic weathering. So now we are moving on to biotic weathering by animals. So burrowing animals, those are the animals that dig through the soil or the ground or through rocks. They aid in the breakdown of rocks. We have some birds that are called sand martins that burrow into sandstone cliffs to build their nest. So they will just get in there. Then we have other types of animals that, as you can see from the pictures here, that do a lot of burrowing as well. So they actually dig into it and causes the rocks to break down. Some of them do that. So this one, for example, this one, this one, this one, this one, they actually dig through. The worms dig through as well, but I'm getting to that shortly. So they actually dig through, they push themselves through the areas that will actually cause the rock to break apart. So if it is very, very, very firm rocks, it will take them some time, but they do break it down eventually. So just their actual force that is breaking through the rocks, that would have been physical biotic weathering by animals. But we do have some other animals that actually break down the rock with their chemical composition. So we have a lot of these. We have a lot of slugs. These slugs, if you've ever seen a slug crawl before, what do you notice that is behind them? So this slime that they leave behind, is actually a chemical. And this chemical is what is left that will actually break down the rock. Okay? So this chemical, which is what is left, will actually break down the rock. So it is not their physical presence, it is not their actual force that is causing the rock to be weathered, but it is the chemicals that they release that is causing the rock to be weathered just the same. Earthworms can do that too, so they can burrow through physically, but when they are burrowing through, they also release chemicals. So that release of chemicals also causes the rocks to disintegrate. Okay, so that would have been biotic weathering by animals, but chemically. So I don't think Jamaican teachers do that. We teach all 3 types of weathering, but there are some persons that will only teach you 2 types of weathering. So they'll just tell you physical weathering and chemical weathering, because plants and animals can fit under physical and they can also fit under chemical. So this one here, with the use of specific examples, explain how biotic weathering can be both physical and chemical.